participants increasing? All right, it's 3:16. Maybe we can get started. This is Masque. If you're wondering what room you're in, we're glad that you're able to join us from your couch. And Chris, do you want to get this going?
Yeah, sure. Let me just go to the next slide.
Hang on. Get to the slide. And there we go.
Lovely. All right. So if this is your first virtual meeting for the IETF this time around, take a minute to familiarize yourself with the new rules, particularly those around queue management. We will need someone to sort of manage the queue. To insert yourself into the queue, just type in +Q into the chat. To remove yourself, do the opposite. And we will do our best to make sure that we address your questions or give you time to speak in the order in which you get into the queue. And if we screw up or mess up, please let us know, preferably by chat, not by stopping over at the mic. Importantly, also, please be sure to mute yourself unless you're video off as well to make sure that everyone has a good experience. And if you haven't done so already, there is a link to the quote blue sheet in the chat, which is Etherpad. Please hop over there and fill out your name to make sure that we track everyone who's here. Next slide, please. This note well, I assume everyone here is familiar with it, but those who are not, again, please take a moment either right now or offline to familiarize yourself with it. Importantly, be polite and respectful and mindful of what you say at the mic or virtual mic, and we should get along swimmingly. Next, please. Right, so quickly, we're just going to go over the plan for the buff and how we expect to, carry out the meeting, and then we'll hop right into the meat and potatoes of the session, starting with Masque. So if you can go to the next slide, we have the agenda specifically. So we'll start with the problem statement and the sort of initial framework that was proposed by David Skenazy, sort of laying the foundation for everyone to make sure we're kind of on the same page. We'll then jump into some use cases that have been discussed on the list and in various channels, sort of leading to this meeting today. This has been an effort ongoing for a couple of years now. As far as I know, it might have been more. And some code in some circumstances or in some companies, and we're going to sort of air those and talk about them and how they're relevant to Masque's mission. Then we'll sort of, from those use cases, talk about the requirements that have been extracted, sort of helping us scope the work of the potentially proposed working group, and then go right into the charter text that falls out of that set of requirements, and then we'll get into the list of BOF questions, sort of trying to get a sense of whether or not folks think we're moving in the right direction, and this is something that has momentum to succeed. Next slide, please. Right, so just reiterate it again. Please, this whole virtual experience is new to everyone, so do your best to sort of be concise and quick, but to the point at the mic. We ask that you only ask clarifying questions until we get to the charter discussion at the end, and if you're venturing into not a clarifying question, we, the chairs, John or myself, will sort of help correct or guide the discussion as needed. Each section that was laid out on the previous slide of the agenda will be, that will end with a particular, a brief pause for questions related to that particular section. So if you can, please hold any of the clarifying questions you have until we get to that point, so we can allow the presenters to get through. That'll allow us to sort of batch up, the questions and hopefully work through any technical oddities that we may experience along the way. And ultimately, at the end, give us more time to speak about the charter and the ultimate buff questions. So with that said, I think we can get started with the next slide. Right. So David, I will hand it off to you. You have 20 minutes, I think, correctly.
Sounds good. All right. Just so my name is David Skenazy. I work at Google. Can someone confirm that you're hearing me correctly?
I hear you.
Yeah.
Perfect. Thank you. All right, let's get started. So today I'm going to talk about kind of the problem statement for Masque. Why are we all here? And the Masque framework, which is an individual proposal of how we could potentially solve the problem statement. Next slide, please. So in today's world and internet, there are times where proxies have really beneficial value. In some cases, for example, they can connect disjoint networks. Let's say if you have two IP networks that aren't reachable at the IP layer, but you have an application gateway. Proxies can also add encryption. And just to clarify here, when I say proxy, I use that term very, very loosely. So a VPN server, such as IPsec or OpenVPN or whatever, is a form of proxy in that you're sending your traffic through there to go to a final destination. Another case is, in some cases, proxies can help you with congestion control. If, for example, the links on either side of the proxy have different properties, sometimes this can increase performance. And so, little diagram to illustrate what I'm talking about. The client will send its traffic to a proxy server, and through that to an eventual destination. So that can be a web server or all sorts of things with an interconnection that can be, in some cases, tunneled in and out of connection. Next slide, please. All right, so what do proxies look like today? So an example is like native HTTP proxying, meaning you can take an HTTP proxy and send it naked get or post commands, and it will like turn around, create connections to other servers and replay those requests. And so that works, but the problem is it only works if what you're trying to get at is HTTP, and also the proxy can see everything that you're requesting and all the responses, which in today's world is pretty much a non-starter for most cases. HTTP also has the connect verb, which allows you to tell the proxy, I want a plain TCP connection to this server IP and port. This is particularly useful, for example, if you want to do TLS end-to-end. So that works really well. It protects your data from the proxy, but it only supports TCP. So if your protocol uses UDP or something else, you're out of luck. SOCKS supports TCP and UDP, but again, the proxy can see a lot of what you're doing, and just setting up, especially for UDP, requires multiple round trips, which in today's world with trying to reduce latency and improve performance is, again, very often a non-starter. IPsec in tunnel mode can offer ways to proxy your traffic kind of with a focus on VPN and that kind of aggregator. Problem is, in some cases, it really requires you to be root on the proxy, which is not always possible for every deployment. And transparent TCP proxies, in some scenarios called TCP accelerators, are devices that are on path and can muck with your TCP. In some cases, they can even improve the performance, but the client really doesn't have a say on whether to use this or not, which isn't great. Next slide, please. So why is this landscape starting to become a problem today? QUIC and HTTP3 are becoming a thing. We're going to publish that RFC sometime soon, I swear. And a lot of the web is going to start using this. So this is a lot of traffic going on the internet that is now running over QUIC and HTTP3. And QUIC has a lot of great properties, such as TLS encryption being mandatory, or encrypting the transport layer information, so the acknowledgements, the sequence numbers, and all that, which break a lot of the existing proxying mechanisms. And also, QUIC is built on top of UDP and not TCP, so the proxies that require TCP don't work with that anymore. So we have a growing need for these use cases were before they used one of the existing proxies, but today with HTTP3 and Quick, we need something else. Next slide, please. The good news is that Quick and HTTP3, while they're kind of creating the problem, they're also providing us with a solution. So what if we used Quick and HTTP3 to build a new proxy protocol? So one of the great features that Quick provides that can help here is multiplexing streams. So inside a given Quick connection, you can have multiple independent reliable streams at the same time. You can also use datagram frames, which is a Quick extension, to send things unreliably, which means that they're not retransmitted. So if you're, let's say, tunneling like raw IP packets or something over Quick, not having them retransmit at this layer can significantly improve performance in some cases. Additionally, HTTP3 brings us like decades of work in HTTP, so a request response mechanism, caching, existing authentication mechanisms, and all this. So all of these combined give us a lot of the tools we need and extensibility for a new proxy protocol. So what this starts to look at on this diagram, which is pretty much the same one as before, is both the outer and the inner connections are now Quick, and things still work. Next slide, please. So what is the Masque framework? The idea behind Masque as currently defined is, so what if we build a application multiplexing mechanism on top of HTTP3? So you do one HTTP3 handshake and TLS key and chain all that entails, and then you can use all these things inside the connection without having to negotiate them. So another important property here is if you're a client device, not all of your traffic will prefer the same proxy protocol. So for example, if what you're trying to do is a TCP flow, then maybe you just use HTTP connect inside this HTTP3 connection that already exists, that you don't even need Masque for that, but that gets you a lot of what you want with very low overhead. But let's say you also want to do Quick. HTTP connect doesn't support that. So what if we built an application that allows you to proxy Quick? And also one of the properties of Quick is packets to have redundant information from one packet to the next, like notably the connection IDs, and also the IP address and port of the server you want to reach on the other side. So what if we compress those away so we don't have to send them on every single packet to really reduce overhead, so your Quick connection has a higher available MTU. And then for things that aren't any of those, in some cases, you just want to be able to proxy raw IP packets. What if you could proxy those in the same connection? And those have overhead, but it's just for those types of traffic that couldn't fit into the previous ones. And all of this is inside one Quick encryption boundary, which allows you to save performance by not redoing key exchanges all the time, but also on-path attackers, let's say your ISP, if you, in your particular model, you don't trust your ISP, they can't really see what you're proxying or what applications you're using, or the fact that you're using multiple of them at the same time. Next slide, please. So the Masque protocol is, so it's an individual draft, and the goal here is not to go into too much detail in the draft, just to say that what we've been talking about, there is a potential straw man for how we could build this. And the goal here is not necessarily to go into too much detail into how that works, just to say that it's possible to solve this problem. So the way it's currently set up is the Masque has a negotiation step using HTTP post. So when the client decides to have a Masque exchange with a Masque server, so it sets up an HTTP3 connection, so that relies on the web PKI, and then it sends an HTTP post where it's a list of the supported Masque applications and their configuration options. And the server responds similarly with, oh yeah, I support these applications you want. And by the way, here's my configuration. For example, I'll allow you to proxy HTTP, but only to these sets of domains, for example. And then as part of this negotiation, Masque kind of reaches down into Quick and says, oh, well, here's a datagram ID or a unidirectional stream ID that you can use. And every time you use those, it'll be allocated to this Masque application. Masque will ensure that it's demultiplexed to that application, and you can use it from here on out. Next slide, please. And that's it. Clarifying questions, please.
Oh, great.
If you'd like to get into the mic queue, please add yourself on the WebEx chat. Christian, you're up.
Yeah, David, I'd like to have a discussion about what is the assumption about resources at the proxy. Can the proxy create ports at will? Is it supposed to do so? Can it operate on a small set of ports? How many clients can we serve, and things like that?
So currently, like the Masque framework itself doesn't make those assumptions. I would put those inside the individual applications. So for example, one thing that Christian and I collaborated on was a version of quick proxying that only needs one port open on the server. But maybe for different use cases, we built different ones. So I think this would be in each application to determine things like that. And as part of negotiation, for example, the server could tell you, well, I only allow you to have this many concurrent connections, or sorry, come back later, I'm out of resources right now.
Mark, you're next.
Can you hear me?
Yep.
Yes.
Yep.
Okay. So, David, I think this is generally good. I just want to have one question. I'm assuming that your use of POST and how it uses HTTP is more of a hand-wavy, this is a way to get it working as a prototype more than actually a proposal. Is that accurate?
So yes, I would say like at this point in time, it's been well, I need a request response. This seems like a natural way to fit it. I would love to get more feedback from folks from the HTTP working group about if there are better ways to do this. But just to be really clear, this is a detail of the individual proposal that I have, not of like Masque in general. So I wouldn't want to get into those details too much today.
Understood. Just wanted to make sure that wasn't set in stone.
Absolutely. None of the protocol bits are set in stone.
Okay.
Martin, you're next.
Thanks for doing this, and I really appreciate the none of the protocol bits are set in stone piece. I'd like to understand a little bit about your thoughts on which one of the many applications you have is critical and which ones maybe aren't so important. You've got quick relaying, you've got TCP relaying, you've got UDP and IP. There's a whole bunch of things in there. Which one of those is most important to you?
I think personally, having quick relaying will make a big difference because over like shoveling raw IP packets back and forth, it will be a significant performance difference, which might be a deal breaker, as in like this will make it viable. So that's one that I focused on so far and implemented. After that, I think having the IP one is important as well, because that is kind of the bottom level catch-all of if for the VPN use case at least that will really do that. But that is kind of my personal take. And I know a lot of other folks interested in Masque have different focuses on other parts of Masque that they think address their use case better.
Thanks.
Eric, you're next, and let me just remind people to please say your full names before you ask.
Yeah, Eric Rescorla. So yeah, I guess maybe this is a question for the chairs. The question Martin just asked is like sort of represented by some text in the charter about the initial set of client-initiated services. We want to have that discussion later or now?
Later, please.
Okay.
Later, I think would be better. This is let's get through the presentations. When we get to the requirements and the charter discussion, I think there'll be a little more just sort of go ahead and surround this, hopefully. Spencer, you're next.
Thank you. Just so nobody's surprised when we get to the end.
Spencer, what's your name?
Spencer Dawkins.
Thank you.
We are having a chat in the Jabber room about whether this is more like a proxy or more like a relay or more like a what, and it seems like we don't need to talk about that now, but just so we don't get to the end and then everybody's surprised when somebody says something about that, because I think that is a relevant point.
Absolutely, and that is clarifying. So one of the downsides here is every single networking term has been overloaded more than 12 times. So I totally agree that some of these terms aren't the best, and I'm open to suggestions, especially in the documents. For example, in some cases, Masque applications, other folks have told me they prefer to call them services, which sounds reasonable. The Masque server, calling it a proxy or not, so hopefully we have enough diagrams in these presentations to make it clear what we're talking about, but I agree that once we reach a point of delivering documents, it would be nice to have a unified terminology, but we're not there yet.
Okay, that's the end of the queue. Let's move on to the next presentation. Maria, do you want to pick this up?
Yes. So this part, I have a few slides to talk about use cases, or actually it's more 2 slides that talk about scenarios that cover a set of use cases. So on the next slide, if you go to that, yes. We have basically a diagram very similar to what you've seen from David's talk right now, where you have the client, the Masque server, and in this case, the Masque server is used to connect to more than one target server. And the benefit you get here is by having a tunnel between the client and the Masque server, that any kind of on-pass observer between the client and the Masque server really just sees your quick tunnel and doesn't see what happens inside. It doesn't see what kind of connections you're having inside and which servers you connect to. So the tunneling provides just an additional layer of encryption, as every kind of VPN does, but it also hides any kind of traffic from the observer. And the goal here is really also to make this traffic not stick out towards other traffic that this observer would see on the path. So it should not be easy for the observer to identify this is Masque traffic. You might get additional benefits if you have a trust relationship between the client and the Masque server, and in that case, we might also want some kind of method to authenticate the client, especially if the Masque server knows the set of clients it should serve. It would also not reveal to anybody else that it's a Masque server. And another benefit with this kind of setup is also that it might increase the privacy of the clients towards the servers, because the Masque server has to put his IP address as a source IP address in there to make sure that the back traffic is routed over the Masque server. And so it will also hide the IP address of the client from the different servers. So this is kind of the basic setup that already provides or covers this kind of use case. If you go on the next slide. This is still kind of the same setup, but just talking about some additional things the Masque server could provide to you. So you could also, because you have this channel, this quick connection between the client and the Masque server, you can also use this connection to talk to the Masque server directly and figure out if the Masque server offers any kind of service to you that could be helpful. Like in this diagram, it just shows as an example service that the Masque server, for example, could resolve some DNS addresses for you. Because you might not have access to your favorite DNS server, or you would like the Masque server to resolve this address from its location, which might be close to you or not. The important part in this image is really this yellow line here, which is the communication channel, and which just means you can, ask additional service to the Masque server, or the Masque server can provide you some additional information. For example, if the Masque server is located in your access network, the Masque server might be able to give you additional information about the current network status. Yeah, so next slide. This slide we put in here because there is a related proposal in the Quick working group, which is called Quick Tunneling. And they focus on a very specific use case where the client is multi-homed. So usually today you have a lot of mobile clients who have a Wi-Fi connection and a 5G connection. And the goal would be here to leverage both connections at the same time. And in their draft, you find this picture here on the slide where they have something that is called a concentrator in the network, which makes it possible to aggregate the traffic. This can be done by, for example, having two quick connections that are used as tunnels on the different network legs. And like all we want to say here is that this concentrator is basically kind of very similar to Masque server, and a Masque server can provide potentially such a functionality as well. And the point here really is to standardize and to work on a common proxy control protocol that can cover a whole set of use cases instead of trying to just like address every use case separately with a different approach. And I think at that point, I give back to the chairs, right?
Yes.
Yes.
Thank you, Maria.
Thanks, Maria. We have a very quick addition to the set of use cases, and this is Cubone. Alex, do you want to go over these slides quickly?
Yes, I'll do. Can everyone hear me?
Yep.
So hi, everyone. My name is Alex Chernohovsky. I work on Google Global Cache, which is Google's content delivery network. And I'm here to talk about Cubone, the quick-based overlay network environment, which is effectively a VPN that we built in order to help manage the Google Global Cache machines. So the problem which we're trying to solve is that we have CDN nodes all around the world, and many of them expose management services which we want to reach from Google data centers, or the data centers expose services that we want to reach from these machines. But for security reasons, we really don't want to expose all of these services on public IP addresses using regular ports. So in the past, we've hidden this traffic through HTTP proxying, and this has not worked particularly well. What we'd really like to be able to do is provide seamless native connectivity to allow services like gRPC or other TLS authenticated things to work directly. So we were challenged with this deployment environment in which ISPs basically filter their networks very heavily. So we knew things like IPsec were unlikely to be available to us. So after looking at a whole bunch of different solutions, we decided to leverage Quick, which we had already shown that we could serve from our machines towards users, to build a VPN and actually be able to hold IP frames. This current diagram shows what the overall architecture here looks like. So on one of the machines in an ISP network, we run a user space VPN client, which itself is providing a tap or ton device to the Linux kernel and sets up IP routing rules to allow native IP traffic to flow through it. This itself establishes a quick tunnel through regular load balancing techniques to a so-called VPN terminator, which is living inside of a Google data center network, which also has the ability to program some software-defined networking routing rules in order to ensure that the response traffic makes it back to the VPN terminator. This allows us to have seamless IP connectivity wrapped in a quick connection. Next slide, please. So why Quick? There's a couple reasons which drove us to Quick over IPsec. The first was the pluggable congestion control. This meant that we could turn it off for the tunneled packets, avoiding the standard TCP over TCP problem. Meant we also had pluggable reliable delivery. We could turn it off because we don't need retransmission, because the inner TCP congestion control and reliable delivery should take care of that as well. Also, because we were implementing on top of GQuick, we also had pluggable authentication. We happened to swap out and use ALTS, which is Google's RPC-based authentication system, and use that internally. And this just goes to show how versatile Quick is and why it's good for this sort of thing. And we also liked Quick because it was already part of the security of things that already run on the public internet. And what we got out as a result is we were able to deploy this VPN at internet scale across ISP backbones connecting back to Google. And we're already serving hundreds of gigs of traffic today for about the last 2 years, connecting our nodes back to our data centers in over 170 countries. So we've actually shown something that I believe was previously not known, that you can in fact run Quick at scale across backbones and have reliable connectivity. We're looking forward to working with the Masque working group that will hopefully be formed today to see how our experience can help feed the Masque drafts. And also we're looking forward to taking back that feedback and moving our changes that we did to Quick to be able to use the standardized form. Thank you.
Great, thanks, Alex.
Yeah, just to be clear, that just to be clear,
John,
that
can you move
I
forward?
just want to say one thing, Chris, that this was a use case that currently uses a sort of a homegrown protocol, and as Alex just pointed out, the hope is that if Masque were to be a reality, then this would move over to Masque eventually. All right, Chris.
Yeah, thanks. So thanks to everyone who's contributed to the list and here today in the use cases, the variety of use cases to help support. We've tried to collate them here. Some of them may be redundant with what's been previously discussed, and some of them might be a bit vague or there are a lot of what we think are important use cases that Masque could help address. And there are probably lots of different designs that people come up with and solutions that people come up with for Masque that could help achieve them, ranging from the very simple to the probably a bit too complex. So I'm not going to reiterate these again based on everyone just having talked about them, but I just want to drive the point home that we're aiming for something that's sort of or flexible and that it can support proxying for both datagrams and possibly stream-based applications. Something that's extensible that can support other services as needed, either in the working group or in some future rechartering of the working group, and potentially with some other, knobs, bells, and whistles if folks think they are truly necessary. So, for example, supporting link-specific congestion control is one thing that was raised. So, next slide, please. Right. So, from the set of use cases, we had a couple meetings over the past couple weeks to try to cull together a set of initial requirements that a Masque solution would help, or that would sort of scope a Masque solution to the previous use cases, and these are the simple ones that we could come up with. I'm sure they're not perfect, nor are they perhaps exhaustive or complete, but hopefully they should get the point across. So just march through them. The first one, proxy negotiation not being visible on the wire, effectively aims to say, aims to say that a connection to a Masque server does not stick out on the wire via some clear text signal. So, for example, if one was to negotiate Masque using an ALPN token as opposed to H3 and then doing negotiation in H3, that's not great. So ideally, the solution does not easily stick out at the connection setup phase, not in the connection use phase later on. So things like traffic analysis that take place or that might occur on active connection that's proxying like IP datagrams or something else is sort of not something that we're trying to hide or putting into requirements right now. The second one is that the use of a proxy is sort of explicit by a client. It's not something that clients can be just sort of coerced into using by virtue of being connected to a particular network, like a transparent TCP PEP, because Quick requires authentication of the proxy. This just seems like a natural requirement that falls out of that. As sort of Jana ahead to the next slide, which was a non-requirement phase. It means like there must be some way to sort of bootstrap and discover these proxies, but we're kind of considering that problem out of scope for the initial working group. We're trying to focus specifically on the Masque protocol itself and the framework that David outlined. The third one, this basically aims to say that each service or application that one might use over Masque is, unique in its own way. It might have its own semantics, and then that negotiating use of that particular service, be it UDP proxying, something simple like that, or DNS resolution, like alluded to earlier, is configurable during the quote negotiation phase. So clients and servers can exchange parameters that control how this particular application or this particular service will be used. And the framework or protocol should support that. Four is just reiterating something that is common to all these, or most of these use cases, that of course we want to support proxying various datagram and stream-based services. And these could be something, primitive things like simple UDP or IP datagrams or TCP connections or streams, or higher level application protocols like HTTP or something like that. The last one, I do not guarantee that the wording on this is correct or accurate or perfect by any means. Basically, what we're trying to say here is that the security context of the connection, the security properties of the connection between the client and the Masque server are completely independent from the security properties of whatever connection you would run through a Masque protocol, or through a other. For example, if you're tunneling TCP or a UDP-based protocol through Masque, the security of that does not depend on the fact that you have tunneled it over Masque or through a quick connection. And I apologize for not articulating that well, but basically the point is that they are separate protocols. They're not meant to be sort of joined at the hip. So if you can move forward to the next slide, please. Like I said, non-requirements explicitly out of scope is building a discovery or bootstrapping mechanism. We will assume that one exists, be it some kind of static configuration, one that's set up by an unauthenticated DHCP option, or delivered by a carrier pigeon or whatever. But actually laying down the specifics for this is not something we'll discuss. I mean, it may influence certain protocol things or decisions, but again, we're not going to charter work specifically to focus on building that. So next slide, I think that's questions. Right, so I don't know where the queue started.
Yep, so the next in line is Martin.
Oh, great.
Yeah, Martin Thompson. Can you go back to slide 22, I think it is, where you have the requirements? Thanks. So I wanted to talk a little bit about number one and what your threat model was, because one of the things that we've identified in using Quick for proxying in various contexts, and I think some of these original ideas came out of the Tor investigations, was that if you have a motivated attacker who has access to both legs of the network, you have the ability to de-anonymize the connection between the linkage between one connection and the other one. So is there some document that I can read that would articulate the sort of goals here?
There is no document. However, I will simply say what my understanding of the threat model is, and then David can chime in if he thinks it's wrong or different or whatever. Effectively, we're assuming a very trivial, simple passive adversary. Someone's typing very loudly. Between the client and the Masque server, whose only ability is to basically look at what's sent in clear text on the wire. And things like any sort of traffic analysis that's more complicated beyond that is assumed not feasible, perhaps incorrectly so. So that's my rationale for it. Not claiming it's correct, but that was what influenced that particular decision. And the idea was that like I was trying to articulate, the configuring of a particular Masque connection would not use like an ALPN token, something simple like that. It would take place over H3 or whatever, something inside the encrypted tunnel. So David, I'll turn it over to you if you want to.
If I may jump in, David Skenazy here. So these right now, in terms of documents, we kind of have two things. We have the charter that we'll discuss later, and then we have kind of a multiple individual proposals. So I can answer at least, this is somewhat discussed in my individual proposal. So this is not, tied to the charter by any means yet. But the idea there is that we would want for an observer on the path to, let's say, if you just talk to a random web server, to not have an obvious way of knowing that this is proxy traffic. It would be nice if it would look like let's say all the clear text bits today, the SNI, the ILPN, things like that, look like web traffic. The traffic analysis is definitely a huge concern, and we'll want to do what we can to address that, but at least it would be important to catch the low-hanging fruit of let's not leave anything in the clear text that make this a big blinking light. Oh, this is proxy traffic, you should block it.
All right, that makes sense. Thanks, David.
Can I ask a question to Martin? Would it help if the threat model that influenced these requirements was they're spelled out either in David's document or elsewhere?
I just really wanted to understand where it was. I had some sort of expectation that someone had already done some of this analysis, and so I went looking for it and didn't see any of it. So there's something in David's draft, not a lot.
Yeah, I think there's some of this feedback is useful. This feedback is useful also because if the set of requirements as listed here are useful for the working group, it might be valuable to add it to the charter. But that's something we can discuss later. Mark, you're next.
DQ'd. I'm going to save it for later for the charter discussion, I think.
All right. Thanks, Mark. Mo, you're up next.
Yes, just to clarify, maybe assumption or restrictions around network topology of client and server. Are those in the traditional sense that the client can be NATed, but the server must be publicly reachable by the proxy? I heard at one point you say something like the proxy may also provide address resolution services, not just name resolution, but is that part of the intent too, to provide stun type of functionality for the clients?
If I could jump in here, is that okay, chairs?
Sure.
Yes, go ahead, Dave.
So the goal here is not to replace stun, churn, ICE, all these things. I think at least my current thought of this, and maybe it's not written down because I just worked with that assumption, is that the Masque server is not behind any kind of NAT and is just a box that from wherever the client is, they can connect to via and resolve the name of. And similarly, what's on the other side should be straightforward, accessible from the proxy to the end server. So I don't think we're trying to reinvent or replace any bits of churn or anything like that here.
Just a reminder to everybody, please say your full name at the mic. Nobody can see you. They cannot look at your badge. So the only clue they've got is what you say at the mic. So that was Mo Zanati. I think that's how I pronounce it. But
yes, sorry, Zanati.
Thank you. Christian, you're next. And please say your name.
Christian Wiedemer. I was wondering what kind of dependency you have on SNI encryption. Because, for example, Chris, you mentioned ALPN, but if you are using echo, the ALPN is encrypted, so it's not visible either.
Right. I'm going to answer based on my understanding. We have no dependency on anything from outside of Quick, or we don't have any dependency on ESNI or Echo, rather. David, I don't know if you want to go.
Yeah, I'll add to that ESNI or encrypted SNI or encrypted client hello are definitely things that could make this better, but currently it does not have a dependency, does not have a requirement. The only dependencies right now are Quick and the Quick datagram extension, if I'm not forgetting anything.
DB3.
All right, I'm going to, a number of people are dequeuing themselves waiting for the charter discussion to start. So let's flow along to the next thing, which is the charter discussion.
Great.
Chris?
Yeah, so I dropped the link here. If folks have access to the slides, and they can follow the link to a Markdown file which has the proposed charter text. We have updated it slightly based on the last version that Eric Kinnear floated around on the list. Thank you, Eric, for putting that together. Again, that's very helpful. So right now, what I'd like to do is just kind of go through each of the three main sections of the proposed charter, and then open the floor to discussion for clarifying questions and larger discussion. So, John, if you could move ahead. Right, so the first thing that we're trying to address in the charter is why this is a particular problem. So this is effectively motivating, or drawing on the motivation that he laid out in his earlier slides, saying that proxying is useful, and that there's lots of different technologies. It'd be nice, basically, if there was one new one that had all the good properties of all of these existing technologies. So not a lot there. We can move on. John, thank you. And so just right into why quick. So we go through some of the high-level points as to why quick is a canon protocol for traffic, all of which should be fairly familiar to those who have been involved in the development of quick and who are here today. So I don't think we need to really talk specifically about this anymore. The next one will be the most interesting. So go to the next. Right. So here's effectively what the Masque group will do. If you haven't read it, I'm going to pause just for a moment to let you read it. Okay, so effectively, the idea is to specify a framework or protocol that allows using various client-initiated services, some of which are listed here, HTTP quick and IP proxying. UDP is sort of obviously omitted, realizing that now. In such a way that the framework or protocol could be extended later on to support additional services or applications as they're needed. As we were saying earlier, the non-requirements specifying things like how discovery or a specific discovery mechanism is explicitly out of scope, though recharting may happen later on to sort of, if we feel the need to pull that in. I'm not going to speculate about the future. And importantly, if this does require any dependencies on other protocols, like for example, if we decide that we need to have a hard dependency on Echo, we would work with the ETL group and other relevant work groups to sort of make or to see that come to completion in a quick and expedient manner. So that's effectively it. We have not laid out a particular set of starting documents from which the proposed working group would start, although the documents that have already been discussed, in particular the core protocol, Masque protocol that David has, does seem like a good fit, or at least a good place to jump off from. And it seems to address some of these use cases. Of course, I don't want to spend too much time on talking about the specific solutions. I'd like to hear from people who are queuing up in the mic as to whether or not this is heading in the right direction. Are there things that should change, et cetera, et cetera. So with that, let's, I'm reading in the chat that we accidentally skipped over Tommy. So Tommy, do you want to ask your question?
Sure, if that's okay. It had a little bit more to do with the requirements, but I think it's also somewhat relevant for the charter discussion.
Great.
Specifically, and I know I'd actually seen the requirements list before, and we had the item that was out of scope for the group, which was how do we bootstrap this? I just wanted to ask for clarification with how much is that out of scope? Do we think that's something that is going to be out of scope, like
always, or just for this initial charter? And specifically, like, if I think about how we look at other things have worked, like Doe. That was a group that didn't describe how you discover it, and right now we're having all this work in ADD about how to do that. But luckily, Doe did define in the URI template how do we communicate about a Doe server, such that at least if I have other discovery mechanisms like DHCP, like PVDs or whatever, we have a way to communicate it. So do we want to at least talk about how do we describe a Masque server, and so that we can embed it in other technologies that allow its discovery?
Yeah, I don't think that's unreasonable. In fact, using Doe as a sort of example for how we expect this to operate is great, because we do want to focus primarily on the protocol and the framework, and leave the additional, possibly more complicated bits to follow-on work that could be done after recharter if necessary. But to your point, I'm not going to say it's out of scope to describe how a Masque server might be represented for the purposes of potentially aiding discovery mechanisms later on. Although I'm curious to hear what the other proponents think about that particular question.
At this point, I'll just call on the proponents to put themselves at the front of the virtual room. You don't have to move anywhere. Just feel free to jump in and respond if you would like. Moving on, Mark, you're next.
Yeah, Mark Nottingham. So I'm looking at this, and I know I just made you proud by saying my name, John. I'm looking at this, and I'm not sure that I see something that I would call, or that it's most helpful to call a new protocol in this, besides for marketing considerations, of course, which we'll leave to the side for the moment. And I say that because, in the quick work, and especially in the HTTP3 work, there's been a work item kind of waiting in the wings that some folks are interested in, which is enabling a particular HTTP request response exchange to flag itself for being delivered unreliably. And the video folks are very interested in this. If you're doing video over HTTP3, you can say, deliver this segment unreliably so I don't have retransmissions crowding out other traffic. And assuming that we find a way to do that and that that's specified, we do that in a generic way. So it wasn't just for video, it would be for a number of applications. And as far as I can see from looking at the use cases and the requirements here, once that's available, using that facility on a connect method would give you the properties that you want, I think, potentially, or at least if we did it right. And in, look at the threat important, and so in the previous discussion, doing it in a generic way that's used in other HTTP traffic would be a real benefit instead of doing it in a way that's specific to this protocol, if you want to call it that. And so I'm wondering if that's the case, whether we should just be waiting for that generic mechanism to surface, hopefully soon, then describe how to apply it to Connect, because Connect is frankly a bit of a mess. It's got some issues because it's somewhat version specific, and we're trying to sort those out currently in the core work. And the result would be probably a fairly small spec. I think you'd focus mostly on, what is the payload in the headers of the Connect and the response to negotiate some application-specific metadata. I'd be really interested to hear, I guess, David's response to that.
Sure. David Skenazy here. So I think for some parts of this could be solved at the HTTP layer. But I think kind of conceptually, the goal here is not to change in any way, shape, or form like HTTP semantics, as in like you still can do the same things with HTTP. But like, for example, one open question, and like some of the drafts address that is, well, for unreliable things like datagrams, even if we were to define something for, let's say, downloading a video unreliably, that would probably use quick datagrams inside an HTTP connection, but it would still require HTTP semantics, and which is normal, and I would expect HTTP working group to provide us with that. But here, I think there are cases for things that are nowhere near HTTP. So for example, let's say I want to transmit a ICMP over this, or just a raw UDP packet of some custom UDP protocol you've never heard of. For those, I think what Masque provides is a way to tell the proxy, I want to have this bucket of UDP bytes sent that way, please. And I wouldn't see that fitting in what HTTP does today, because those are different semantics. I hope that answers your question.
Not really. I guess I was just talking about an unreliable connect effectively, which you can dump pretty much anything into bidirectionally.
Yeah, here's Mary Filament, so can I jump in as well? So I do agree with you that like this connect method could provide very similar functionality. But to be honest, I mean, HTTP Connect is really a hack, right? It's not really part of the main, or it's not like the HTTP protocol using, it's really just something to indicate forwarding. And that is very similar to what we want. But I think some of the use cases we have, it doesn't have to be HTTP specific. And so it makes sense maybe to utilize the fact that it doesn't have to be HTTP specific to optimize for those cases a little bit more.
I guess that comes back to the original. It does get a little bit with how the bits are on the wire. Is this an HTTP extension? It sounds an awful lot like it is one. So maybe it's just better connect? Or are you really talking about a new quick protocol?
Definitely not a new quick protocol, but something on top of quick.
On top of quick or on top of HTTP3?
No, I think it could be on top of quick. So I think the requirement for HTTP is really about making this look like web traffic, which is HTTP. But the proxying protocol itself doesn't have to have any dependencies on it in HTTP.
So are you going to multiplex it with HTTP3, or does it have to have a distinguished port?
So if I could jump in here, I think, so this gets into the details of the wire format because, and semantics, or I guess this is an open question where if, we started off as HTTP, I personally would like to use HTTP so we can reuse HTTP semantics for parts of Masque, but I don't kind of envision this as just things tacked onto HTTP. I think it would be like enough of a change that I wouldn't necessarily call it HTTP anymore. But I totally see that this is the kind of conversation that we all love because it's all in semantics and we can look at the same thing and see very different things because of our backgrounds. So I would say this is really great, but I don't have a good answer yet. I think we'd have to get more into the solution space to see where that goes.
Okay, then I guess from my perspective, I'll end with, to me, before something gets chartered, it seems really fundamental that you define whether or not you're defining a new application protocol on top of Quick, or you're defining an extension to an existing protocol. I don't think you can charter without doing that.
I think that's a fair point. This might be a discussion to have about exactly how this is defined. Go ahead, David.
Yeah, no, and I totally agree with Mark there. I see this as a different protocol, given that like the use cases and constraints are very different. And that's why I think it would make sense to have it in its own working group, because the questions asked would be pretty different from the ones in the HTTP working group. But I mean, part of why we're here in this BOV is to figure that out.
Okay.
All right.
Then whether or not it's multiplexed with HTTP traffic seems like a really critical definition between the two.
Hey, Mark, just to put you on the spot there, if you look at the last paragraph on this page, right, it says if it requires extensions to any existing protocols, this group should coordinate with that group. Does that kind of answer at least some part of your question that if we have to do some extensions, we go back to where this needs to happen?
I think Mark,
sorry, can I answer real quick? I think potentially yes. My concern that you're hearing probably behind what I'm asking is that going and doing things like redefining connect or defining new methods and things are fairly invasive changes to HTTP, and there's a lot of pitfalls there. So it would have to be a very close coordination.
Okay, sounds good. Thank you.
Yeah, I think another way perhaps of echoing this might be, the question is if this belongs in a separate working group, or are there pieces that belong in those individual working groups directly? And that's a perfectly fair question, I think.
That may be a good solution too, yeah.
Okay, thank you for that, Mark. Next is Martin Thompson. Are you there, Martin?
Having audio troubles, so I
there you go.
might have to reload. I apologize if I drop out. So the very first line of the charter says that proxying is good, but it doesn't say why it's good. And I think saying why it's good would be very important in this context. Understanding what properties we're looking for out of proxying would be, I think, critical. I think we're looking for the privacy aspects of it, but that's not clear from the charter. Second point is just say no. I think was right in the sense that if we're going to be doing things within H3 and pretending that it is H3, then it is H3. Let's not pretend. And that means the last paragraph.
Martin, can you repeat that last point? You dropped out there for a moment.
I'm sorry. I blame the NBN. But if we're making changes to HTTP 3 such that we're able to do these sorts of things, then it is H3, and the last paragraph of the charter probably needs to be amended. And we need to coordinate even more closely with the line between pretending and actually modifying the protocol is much finer than I think we're giving credit.
Sounds like, David, do you want to say something to this, or do any of the proponents want to speak to this?
So I had a hard time on hearing and understanding Martin, sorry.
Why don't we move this to Martin, maybe you could bring this up on Jabber. I didn't want to misrepresent you. I heard you for the most part, but I don't want to speak out of turn here. Moving on, let's go to Eric.
Howdy, Eric Rescorla. So Mark said some of what I was going to say. I guess when I first heard about this, I envisioned this as like super connect, i.e. connect with unreliable, and maybe we'd like clean up some of the semantics. That's something I'm quite interested in. We have things that use connect, and we love them to be unreliable. I'm much less enthusiastic about sort of this, application-specific stuff like Quick and DNS. I think like we should just offer, I think we should start by offering like basically UDP and TCP and see how like that shakes out. At which point this seems like a relatively modest extension to HTTP and Quick. And I think clearly, I read these proposals, and these David's proposals clearly like a H3 extension. It's not like some new quickie thing. I think that'd be a good idea. And I'm now that I'm no longer in AD, I'm allowed to be totally ambivalent about whether it is an HTTP or a working group Quick. But I think that like it's relatively small, so it should be done quickly no matter what it is.
So if I may respond to Ecker, this kind of goes back to semantics, where I totally agree with you that it's not that much work to add these things. And if we end up building it as like the current Masque proposal, or if we end up building it as like a new HTTP verb, for example, I think that's something that we should decide as a Masque working group, hypothetically, if it were formed. I understand that for your use case, the like UDP connect is completely sufficient, but I'm not sure that's the case for all the proponents of this BOF. And so building something that is extensible might have value. But I do think that this is something that doesn't need to be nailed down today. It needs to, it would be, if we need to solve this and there are people who want to solve it, let's get together, form a working group, and decide how to solve it.
Well, so yes and no. So certainly, I think the cases I saw might need IP connect, and I think extensibility is good. Obviously, extensibility is a good feature. However, it's not totally something we can put today, because if you read the charter text, it strongly implies that we build a quick specific, an HTTP quick specific service, and that's actually something I don't think we should do. And so I'm not prepared to have it chartered with that in the charter.
So Ecker, could I ask you to clarify why you think we shouldn't do this? So you don't have a use for it, but some other folks might.
I think it's a necessary complexity that can be served by these other cases, and I haven't heard a strong rationale for why this should exist. And the fewer things.
So hang on for one. So just I'm gonna interrupt you briefly. Maria, did you have something to say?
I wanted to ask Ecker a clarifying question on his note. So when you say you want some kind of super connect, is it important for you that it's actually HTTP based, or is it just a functionality that the super connect would provide you that you're looking for?
Well, I guess so. I mean, this goes back, I think, to some discussions I had back and forth in Java, in the sense that for many of the cases we're interested in, you can just get by, like term would do the job, right? I mean, this in some respects is like term with different spelling. And so in what way is it better than term? It's better than term that people want to run like H3 like servers and want to run quick servers. And so for the same reason as web transport, people think they want, and Rift, people think they want to have like H3, having this be some other goofy thing that is quick and not and not H3 seems like quite problematic. Given that the first requirement here was about like not sticking out, I don't see how you're going to do that if you're not H3, if you're not basically H3, unless you're going to have a dependency on echo.
So I'm going to move forward in the.
Please.
I think there's some echoes here. Anyways, no, metaphorical echoes, not literal echoes. Bernard, you're next.
Okay, I'd like to follow up on some of what Ecker's just talked about. I think there's a question about scope here. We've talked a lot about the framework, but I have some questions about the overall protocols that we're looking to support down the road. I think it has to be relatively clear what the overall scope is, because it's very difficult to answer, for example, some of the questions that Ecker asked about this threat model when you don't know ultimately what are all the apps you're going to support. So it becomes, are we trying to allow something like Tor? Also, with respect to some of the protocols we've talked about are well defined and are being standardized. The working groups like DOE and stuff like that. Some of them, like the tunneling work that's been discussed, are not currently being standardized. So I would want to understand, for the things that we do here within the framework, where are the actual protocols being defined, and is there a working group that works on them for each thing that is included within this framework?
So I think the goal, David Skenazy here, of the bold sentence in the first paragraph that is currently on the screen is to say that the main deliverable of the Masque working group, hypothetically, would be this framework and then a small set of applications, because I don't think, you can, in order to define a good framework, you need to define at least a couple applications to make sure it works well. And then once we're there, then it would probably be, after a recharter, still in the purview of this working group to define new ones. But the security model of Masque itself should be really seen in the light of just the framework and have just a security model that's well defined. And then the applications would then decide if their requirements are met by the security model, if they want to build something on top of Masque.
All right. Ben Schwartz, you're next in line.
Hi, Ben Schwartz. I mostly wanted to say that all I really want is IP over web transport. All this other stuff sounds okay, but that's basically what I want, or something morally equivalent.
Ben, can you clarify what you mean by web transport here? Because that's that's been overloaded 15 times by now, I think.
Well, web transport is, a pretty specific proposal, in both the W3C and the IETF. I want, it provides a message-oriented transport. I just want to put IP datagrams in those boxes. and ship them back and forth. It's it's so simple it almost doesn't, it's like a 3-word RFC.
If I might jump in to answer that one, as a Masque enthusiast and also chair of WebTrans. So there is definitely a lot of similarities between Masque and WebTransport, absolutely. They're both, hey, how do we ferry stuff on top of Quick? There's this new Quick thing, we should do cool things with it. But the requirements are very different. And so the goal of WebTransport very clearly is to have something that is accessible to the web. So the focus is the web security model and taking things from WebSocket and revamping that in the world of Quick. So let's say, how do we do WebSocket, but with UDP? But the goal there is to make it accessible to the web, and by that I mean JavaScript running in a browser. If what you're trying to do with IP here is a VPN client, you can't do that from inside a browser, and you really shouldn't trust your entire VPN stack to be something in JavaScript. So I think that doing IP over quick datagrams is definitely useful, but I'm not sure WebTransport is the right way to say that, and hence Masque.
Sure. So I'm not particularly proposing to implement this in JavaScript, although I think it's actually, there might be some use cases where that's interesting, but it's not the use case we're focused on. But my point is mostly that at the protocol level, essentially ignoring the W3C components, looking solely at the IETF components of WebTransport, that you could just throw some IP packets on top of it, and that would fit the bill here. And so we can invent some more stuff if we want, but there are some essentially reusable components that we can just stick together and call it a day. And I brought this up partly as a counterpoint to what Mark Nottingham was mentioning, where I just have some difficulty believing that the HTTP working group is really going to standardize a component of HTTP itself that will let us ship an arbitrary IP datagram to an arbitrary IP destination.
All right. Ted, you're up next.
Ted Hardy speaking. If you go to the charter text on slide 26 that describes the motivations for the work, I don't believe it actually motivates any of the work that would have the proxy deliver services outside of sort of wrapping and unwrapping packets at one end of the spectrum and acting as an HTTP connect proxy at the other. And I think if you go back to 28, sorry to ask you to flip around, Jonah, if you go to the section that says specifying Masque server discovery is out of scope for the group, I think a combination of that really indicates that you almost are talking, given the spread of things that came before the charter, about 3 different groups of proxy types. You have one proxy type, which is essentially acting as a VPN endpoint. It's going to ship IP packets to whoever it was told to ship them to on the inner part of the tunnel and call it a day. You have what Lucas has talked about in the Jabber chat, which is essentially an HTTPS proxy for HTTP3. And you have this sort of generalized thing where it's offering services to the endpoint over Quick, which might be DNS. So it's not acting, to go back to the figure, it's not a blue line where the client tells the proxy server, go to this DNS server and ask this question, pass this traffic to that DNS server, but instead is asking it to do the resolution on behalf. And I realize that what the charter is saying is it wants to build a framework, but I think at this point you're asking it to deliver both chalk and cheese. And building a framework that's going to deliver both of those may not be the most effective way to do that. If in fact you've got 3 different goals, 3 different documents, and 3 different approaches may be the right way to resolve this. And I think the charter needs to be really clear in its selection of what its primary use case is, because what I'm reading in sort of the side channel here is that there's a pretty fundamental disagreement about whether this is a, everything over Masque type VPN, or whether this is in fact an HTTP proxy that works with QUIC. And I think much of the presentations up to this point kind of assumed we could do all of that in a framework, and I'm becoming less and less convinced of that as the conversations go forward.
I would like to reply to that one. So we did kind of have, when we first started, as the proponents came together about this, we had kind of the same problems, like we have to have different use cases. Is that really the same solution? And the more we were talking about it, we actually detected that it's the same solution, because the basic mechanism or the basic function you need here is really just forwarding, and everything else you can build on top of that. And the point is here, it's not the kind of forwarding you have with SOX or whatever today, where you have to open a different connection for every thing you want to forward. It's really, you have already this outer quick tunnel, and it is there, and you can just use it, and you can build things on top of this forwarding, given you have a direct connection between the client and the proxy. And I think that's the big benefit here, to not go and separate and build like 3 times the same protocol, but trying to actually have one protocol that can address many of the use cases and can be flexible and extendable, so it can actually also cover future use cases.
I'm going to cut the line here after Cullen, because we have about 10 minutes and about 10 people in queue right now. So if everybody could keep their questions and responses short, that would be helpful. Ian, you're next. Ian Sweat. Ian can come back in queue. Maybe there's an audio issue. Spencer, you're next.
Where to start? Thank you all for bringing this proposal forward, and I'd really like to thank people on focusing on the different use cases that people were thinking about, because I think that really got us out of the we're hiding all of our servers place that this kind of started, and turned this into something that a lot more people can work on. I think that getting to be really crisp about what this is most like, because I think people are kind of seeing this as a relay, or this is a tunneling mechanism, or this is a proxy, or something like that. And I think ditching a certain amount of the first paragraph, where it's like, these are kind of middle boxes. So those were middle boxes, but what are we really going to do? I think that that's going to be important. I think that that was one. Number two, on the thing on discovery, having that be out of scope for this would make me feel better if we had some idea where that was headed. Like, are there mechanisms that we could point to now and things like that that would make us feel better about this? I mean, I just didn't want this to turn back into host.txt as a way of configuring this, or the moral equivalent of that. And the third thing I wanted to say was we heard, on like Cubone and things like that, we're hearing things where we're kind of talking about the way QUIC can be, but it's not that quite yet. Is this unreliable, or is this datagrams, or what needs to be part of QUIC that's not part of QUIC now? And I think that because we've got the thing in the charter about we punt to the other working groups, but just if we're going into this knowing that we have gaps, being real clear about that up front would be helpful also. And I'll stop by saying, I don't know that we're going to have another face-to-face IETF this year, so I'm definitely I'm definitely up for continuing to discuss this either at the use case level or the charter level or both on email, and seeing how quickly we can move this forward, because I would like something like what I think Masque is to go forward. Thank you.
Thank you, Spencer. I think, yeah, we need to be more crisp in the charter. I think that will help a lot of people, actually.
Yeah.
Ian, do you want to try one more time?
Now that we're all motivated to send pull requests.
That would be helpful. I'm going to move on to Ian. If you can try one more time. Nope, cannot hear you, Ian. Okay, I'll have to move along. And again, if you want to come back in, let me know. Tarek, you're next.
So I'm wondering if this is completely off. I'm sorry, but
can you please state your name for the
reason why you don't want to? I'm sorry, Carrick Bartle. So the benefit of this over doing just quick inside quick is the compression. But am I misunderstanding, or is there like an additional round trip between, like there's an additional mass negotiation that has to happen before quick, right? So are you like trading off time for bandwidth or latency for bandwidth, or am I missing something like an additional benefit of Masque over quick, inside quick?
So if I may answer that, David Skanazi here. I'm not sure I understand your question. Quick inside quick doesn't exist today. So one of the goals here is to make that a reality. And so by quick inside quick, I'm saying like, sorry, go ahead.
You're saying that's not possible right now?
Well, what I'm saying is today, quick with HTTP 3 on top allows you to do gets and posts and whatever is HTTP semantics your heart desire. To say, hey, HTTP 3 server, I want you to proxy this quick packet to this other server over there. There's no way to do that today.
Okay. That answers my question.
Yeah, I would like to, here's Mary Sullivan. I would like to add that I don't think it necessarily has to add another round trip time. It depends on how we design this kind of negotiation protocol, and the negotiation protocol might be only the client instructing the server to do something because it already knows the capabilities of the server. So you could basically, in the same round trip time, instruct the server to do something and send the data you want to forward.
Thank you. Next is Alex. We can't hear you, Alex. Are you trying to speak?
Move on to the next person.
Yep, let's move on. Jonathan Lennox.
Hello, Jonathan Lennox. I assume I'm audible?
Yes.
Good. So I guess I certainly have the concern, I think somebody mentioned this on the Jabber, this will be an XKCD 927 problem. So I guess my question is, to what extent would, turn over quick and or SOC 6 over quick, or possibly either of them over WebTrans, meet the requirements, and to what extent will they not? Because I'd rather, there's been, I think as Ecker mentioned, there's been a lot of existing semantics work done, which, it's better not to reinvent things we already have unless there's a good reason for it. And maybe even if they're different, that's a good reason. But if they're the same and then I think that's not a good. Then we should not try to reinvent the wheel yet again. We have enough wheels as it is.
Do you want to answer this, David?
So I apologize. This is what I tried to address this in my slides. We have a bunch of wheels, but quick kind of showed up and kind of proved to us that a lot of those wheels don't fit the bill anymore. So something needs to be done. And honestly, the output of the Masque working group doesn't need to be, a brand new shiny protocol of its own name. As Eker and MNOT were saying, if this ends up being, let's say, I don't know, methods in HTTP, maybe we just add a few spokes to the wheels we have, and that's totally an option. I really like the current individual draft is its own thing because that was just an easier thing to get up and off the ground, but I think that is a perfectly reasonable discussion to have inside the working group.
Thanks, David. Watson Ladd.
Watson Ladd here. So I have a question that's might be relatively narrow, but it's about the impact of congestion control. I mean, I see slides with quick and quick. Won't this only, given that the inner quick is encrypted, won't this only really work if you have unreliability of the packets that you're sending those inner quick packets in, to avoid the problems of TCP and TCP where all sorts of bad things happen?
This is Mia Kulevin. So it depends on really what the scenario is, and that's why we actually want to have these different services that you can request from the proxy. But there are scenarios where you can also use this on a reliable stream for local recovery. If you have a very short little or small delay link, but it has high loss, just having a reliable tunnel there can be very beneficial. We've been testing that. And in this case, the congestion control within congestion control isn't such a big problem because the timescales are so different. So the answer is it depends.
If I could add something there as well. So for something, let's say this is the scenario. We're tunneling TCP over IP over this for some reason. And yes, if you do TCP over TCP, performance is bad. We have an ample amount of papers demonstrating that. But the important thing here is that what makes this bad is one of two things that are often conflated. One is congestion control, and the other is recovery. And so when you do TCP and TCP, you have two nested recovery loops that retransmit things. And so you can end up having data retransmit at two layers, even though it's useless. So that's what's really bad. Nested congestion control, however, is not bad. If you look at any router on the internet today, assuming you're speaking to something on the internet that is multiple hops away, your router has a queue, and you can call that queue management algorithm a type of congestion control. If there's more coming in on one side than the other, it will drop packets to rate limit you. So having this level of nested congestion control actually is no different than just having a node or router on your path that is dropping you if you're going too fast. So I do think it's really important that we use quick datagrams to avoid the nested recovery, but I think the nested congestion control is not necessarily a problem.
So I'd like to speak to that as an individual, but I'm not going to get into it now. I think this is an interesting question, but it's not something that we need to get into at this point. Next up is Martin, but Martin DQ'd himself. I'm going to go on to Tommy. Tommy, you're up next.
All right, thanks. Sorry for the delay. This is Tommy Pauly. This is going back a little bit to the comments that Ben made about the relationship with web transport. I think that's a really interesting thing to bring up, and kind of merging the approach and the protocol bits could actually make a lot of sense. I do want to encourage, to David's response saying that there are different use cases and different motivations. I want to encourage that we shouldn't be defining things separately in different groups and different knobs within the same protocol as H3, just because one comes from a VPN approach and one comes from the W3C and JavaScript. They can both rely on the same protocol knobs. Of course, I think that would add a question of how would supporting these interests affect the web transport charter if those documents were to help include some of the HTTP bits that were necessary for this. And at the very least, I think for the purpose of this charter, you should add a touch point with WebTrans listed in the groups that we need to talk to, if this is a group.
That makes sense.
Yes, I agree to that, yes.
We want to make sure we don't have any work repeating. Luckily, a lot of the folks involved here are involved there, but you're right, let's spell that out in the charter.
All right. Mark, you're up next.
Yeah, Mark Nottingham. I just wanted to briefly say, respond to one of the comments that Ben Schwartz made, which was he didn't see the HTTP working group delivering a mechanism to ship arbitrary IP packets, I think it was. I don't see any reason why not. We already have Connect. We just need the reliability. I don't think that's out of scope or even terribly controversial there.
Thanks, Mark. Cullen, you're up next.
Cullen Jennings. So this is not just a proxy, it's also a NAT when you really think about it. And so when I see things like IP proxying in it and people talking about receiving ICMP messages, I think that the charter needs to say a lot more about how, which on the upstream side of this, not the downstream side, who can send packets back and get them into a connection, who can initiate this. And this all comes around the really, can you use this to run servers and all of those issues, and how will that all work? I mean, you know, if I have an IP address and I'm just sending it to IPs, can any other IP send it and I get the packet? If so, how do you NAT that and all of those issues? I think there's, the charter is it's thinking about it very much as everything's initiated from the downstream side, but it doesn't talk about initiation from the upstream side at all. So I'd like to see the charter a little clearer in that scope.
If I could answer that, David Skenazy. So Colin, that's a really good point. Like, I'm not entirely sure it needs to be in the charter, though. It'll absolutely need to be in the document that defines how to do this. There are really important and very subtle security considerations that are going to be needed on how to do this right. I guess maybe just a sentence in the charter saying, yeah, don't mess this up. But I would really see this more as a deliverable in the documents.
Well, fair enough, but I think it'd be good to be clear then that we, in the charter, that we expect to be able to run servers on it and receive stuff from a broad set of connections, or we don't expect that one way or the other, because that definitely splits it. I agree the security considerations how to do that are going to be really complicated, but all right, it'd be good to understand what people's goal is.
Yeah, I think this is, go on,
yeah, I'm not sure I'm understanding this 100% yet, because so in the diagram we had, I think the term client, Masque server, and target server, they were more indicating, you know, where the tunnel is. And we always say the tunnel is between the client and the Masque server. But it doesn't really mean what the actual application connection does do here. So I'm not sure what you're looking for. What's the scenario you have in mind?
Well, if I send a packet, so if a client sends up to the Masque server and says, please send this IP packet to IP address X,
yes,
and then it gets back an ICMP address from Y, is it supposed to forward that back to the client? What if it just gets a reply back to the same IP to Y? Does it need a unique IP for every single client behind this? I mean, when I read this charter here, it seems like you're saying all of those things at once. And that, if that's the goal, this is a very, very broad. Right?
No, yeah, I don't think that's the goal, and that's thanks, Colin, for isolating that. I think what we'll want is to say, no, the client has expressed interest in tunneling to this destination. So if you have packets on the return path, send it to the client, and if you have weird packets that you don't understand, maybe drop them on the floor. But yeah, that should be clarified. It was kind of a working assumption that we forgot to document.
I get what you just, so back to the NAT question, that makes sense when you're using UDP or TCP or QUIC or something on top of those. Does what you said just make sense in the context of IP? And I'll end there. I won't take any more time. I apologize.
It really depends at what layer you're proxying and all these things. And I agree with you that this gets into very itty-gritty details. So maybe let's take it off list. But I agree that this should be clarified. Fair.
But I mean, I understand the problem now, and I think we need to work on that. But I'm not sure if it has to be in the charter. For me, that's really some of the details of the protocol that need to be specified.
All right, I'm going to move this along. Ian had one comment, which I'm going to relay at the mic here. He says we should pursue this work, but we need to determine whether it's over Quick or over HTTP3 before creating the working group. And this is more for the Quick chairs. This work makes me think that datagram may be needed in Quick V1, or datagram might be useful to have in Quick V1 for this work. Any more thoughts on that? But we're not going to do that discussion here. I hope what I said was clear. And we are going to move on to the next phase of this in the last 20 minutes that we have, which is the BOF questions. Chris, do you want to take this?
Yeah, can you advance the slides, please?
Hang on. I am apparently resizing. I have no idea what I've not done anything. I've not even gone to the slides.
No, you're good now.
Colin.
Okay.
This is Cisco. Sorry.
Right. So thanks everyone on the feedback on the charter. We will work after this to sort of clarify several of the key points that were raised, in particular around clearing up motivating text in the charter model, trying to suss out whether or not this is a new protocol or an extension of a protocol, the Quick versus HTTP3 thing, and other issues that I've made note of here. So in the time that's left, we want to get a sense of whether this is something that we want to go forward with in the IETF. Typical BOF questions. And so in the interest of time, I think the way we'll do this is I will just pose the question. There will not be a hum of any particular type. Just want to hear what people think. So, please queue up to the mic if you have disagreements with what's written here, or disagreements with what I'm saying right now. Thank you, Mark. And we can go through there. All right, Mark, I'll turn it over to you quickly before we get started.
Oh, sorry, I misunderstood. I wanted to answer the question.
Now you have to wait 20 minutes before you can talk again. Okay, so I'm kidding, of course. So the first one, admittedly, there was a lot of question about the specificity in the charter text as proposed, but I imagine that's something we can work through. But at a general level, I'd like to know or hear from folks whether or not you think effectively the scope of the problem that we're trying to solve was laid out in the motivating text from David and the proposed case that we described and the motivating charter, proposed charter text is well defined and well understood. And if not, what are the particular, perhaps you can shed some light on what are the particular areas in which more refinement is necessary or needed, and what we might be able to do to better clarify them for the understanding of everyone. So, Ecker, I think you're up, unless Mark wants to.
Okay. So I guess I came into this thinking that they were well defined and well understood, and then I thought that it was basically what I think Cullen would call a symmetric NAT, namely you'd be able to make outgoing connections with like UDP and like we can fight about this Quick versus HTTP thing later, but basically be like outgoing. But as Cullen points out, basically the question of whether there's going to be server functionality, server capable functionality, or raw IP capable functionality are like kind of like real scope questions for the working group. So I think I guess I would argue they shouldn't be, in which case I think that the scope is well understood. But if the people think that they should be, then probably need to get up.
Yeah, that's a fair point. Mark, do you want to go next?
Sure. Mark Nottingham. Yeah, I agree with what Ecker says. I think the abstractions that are being forwarded really need to be nailed down to the charter. I don't agree that this could be sorted out in the working group because people are going to come in with wildly different expectations and it's going to cause a lot of friction. I also think it needs to be defined crisply whether this is a new protocol on top of Quick or whether it is HTTP3 extension or extensions or something else.
Ben, you're next.
Okay, so clearly the scope is not universally well understood. I don't think that we need to fully specify the layering. I think the key requirement that I do think we could get consensus on here for the charter is to say that this protocol can run inside a quick association alongside HTTP, inside a quick association that is owned by HTTP3.
Okay.
Who's next?
Watson?
Was that me next?
Yes, Watson.
Yes.
Oh, yeah, okay. I think the scope of the problem, it seems that there's a lot of questions about whether or not things like whether it's just forwarding connections at connection layer or application or IP layer, and if you want to support all of those, are those all connected? So I think that's an area that I'd like to see more clarity on.
Sorry, can you reiterate, Watson?
Yeah, so when we're talking about something like we want to forward, we want to proxy HTTP, we want to proxy Quick, we want to proxy TCP, we want to proxy IP. These are all different things. And are they all going to be available all the time? Are there going to be, is it going to be sort of a menu? Is it going to be, are these going to layer on top of each other? So the way we forward Quick is the way we forward UDP. It's just that there's a connection, or is it going to do other sorts of things? Is it going to forward individual streams and be aware of the streams inside the inner one? These are sort of big-ish questions, and you can see it's like the difference between HTTP proxy versus passing HTTP over IPsec.
Yeah, okay. I do agree that certainly a clarity on what is the minimal functionality that the Masque server will provide is certainly needed.
Yeah, and this does run into the negotiation question of exactly what services are in fact negotiated and how they are. And that is definitely not something that is in the charter at the moment. But yeah. I think the next up is Martin.
Yeah, Martin Thompson. One of the comments that I made earlier that got cut off due to audio troubles was that there's a lot of discussion in this charter about frameworks, and nothing in the discussion that we've had so far suggests that any need for a framework at all. And while the point that Eka raised, I think, is probably the biggest one, this discussion of frameworks makes me deeply concerned. I don't think we need one at all. I'd rather see that jettisoned.
Can you clarify what you mean by a framework?
Yeah.
What your understanding of the framework is? Just to make sure we're...
So it's kind of ambiguous in the current set of proposals, but there is a framework at the moment for, I guess, discovery of capabilities and so forth, and I don't think that's very well formulated. But the suggestion, well, I could extrapolate from there and say that there's possible things that are shared across quick proxying versus IP proxying versus UDP proxying versus TCP proxying that all require the same sort of signaling. And I'm not seeing any motivation for that, and I would rather see that go.
Okay, thank you.
If I could, sure. David Skenazi here. So the reason in my individual proposal I currently have a framework is that if the use case, like the use case that I'm personally passionate about is a VPN client. And if you're building a VPN client, as I shortly alluded to earlier in my slides, you might be ferrying very different kinds of traffic based on what your users are doing. And these different kinds of traffic don't necessarily need or want the same kind of proxying. And so maybe framework is a bad choice of words, but the idea was, what if we allow having multiple things inside this same connection to my proxy in a way that's not visible to unpath observers? And I think that's, for me, the main justification for having what I call the framework, which is to be able to have multiple of these at the same time.
That's okay. You can use the word multiplexing in that case, and then I don't think we have any problem.
Okay, yeah, that is the only thing I meant by that.
Okay, that makes a whole lot.
I think make a note to fix that.
I think it's actually useful. This is good, because I think framework might confuse a lot of people. It's a very general term, and being more specific is something that we could do in the current charter. That's one of the pieces of feedback I'm taking back, is that the charter needs to certainly be more crisp, and this is a very precise suggestion here. The next in line is Mike Bishop.
So I feel like there are a lot of scenarios here.
Sorry, Mike, you were cut off at the beginning there. Can you start again?
Mike Bishop, I feel like there are a lot of scenarios here, and I'm not sure that we actually need to solve all of them, because solving some of them would give you the means to solve the others. So, like, you know, I don't know that we care about HTTP proxying if you can do TCP. You can do quick if there's H3 support on the other side. Generic IP flows seem like what you'd want for a VPN. Then, you know, symmetric NAT versus cone NAT versus routing. And I feel like the scope that has been presented is a little bit overbroad, and different people have different conceptions of what they're trying to achieve. So I'd want to see a smaller list of scenarios before we move forward with this. And the second piece, we've been discussing in Jabber different ways that you could build this on as an H3 extension with unidirectional streams, or the bidirectional streams we don't use, or a new connect method. But honestly, I think if you're going to do something like this, your cleanest path is just call it a new protocol and take a dependency on echo to hide what protocol you're negotiating.
Yep, that's.
Thanks, Mike. To your first point, it very well might be that the actual solution is, you know, a simple proxying protocol for UDP and TCP and applications, and everything is built on top of that. It might have some additional extensibility points, but I don't want to get too specific into the solutions right now. So I want to cut it here because we still have a couple more questions to get through. So my understanding is that effectively that despite sort of lack of clarity and crispness with how we specified the problem and what we're actually trying to solve, that there is some interest in, you know, sort of working on, you know, some subset of this. And I think the challenge will be to sort of articulate what that particular subset is in a meaningful way. So I guess to that end, the next two questions are really about folks here, proponents of the BOF, interested parties, trying to understand whether or not there's people who are interested in reviewing documents in any capacity, be it commenting on the mailing list or on GitHub or wherever it lives, or even serving as an editor. So I don't think you know, folks need to say anything. If you want to just like +1 or something in the chat to indicate that you have an interest in either one of these things, that would be lovely. And we can kind of just put that and move on.
I'm sorry, did you want us to do that in the chat, which goes away at the end of this, or in Jabber?
Yeah, we just want to get a quick sense for it right now. You can do it in the chat here or Jabber.
Let's stick with the chat. Oh, well, if it's happening on Jabber, then I'm not going to stop.
All right, great. So people are chiming in. Thank you very much. So that brings us to the last question, particularly around the existing charter, the proposed charter, and working group formation. We felt it was not appropriate to specifically ask if a working group should be formed with this charter text in mind, as we've discovered throughout the course of this meeting, there are some textual edits that could be made to the charter, as well as some content refinements that could be made as well to sort of help set it on a trajectory for success. So we will work offline to sort of address those, but I'd like to take a step back and sort of ask the more general question about whether or not anyone feels like a working group should not be formed to address a problem of this type. And I'm not going to specify exactly the problem we have in mind, because that's for problem or question number one that's still being fleshed out in more detail.
And just to jump in there very briefly, Chris, we have about 20 plus ones for the community participation question. So I think it's safe to say that there's a fair amount of good requests, and a number of them are about contributing, people willing to write and contribute to the work, which is excellent. Okay, so more than 20 at this point. So that is very good. And just in the last question, I wanted to add that let's be careful here. The important thing here is to state if you believe that the working group should not be formed. We have heard, I think the problem statement and the question of scope, as Chris mentioned earlier, is very clear. We do need to work on that in terms of the charter. But I would like to move on to quick questions on the last one. Chris, did you want to say something else before I move on to questions on this?
No, let's please move on to questions. I think if I'm reading this correctly, Ted is up first.
Ted is up first.
Ted Hardy speaking. I think until you have the scope problem solved, I would not agree that a working group should be formed, because you might want more than one working group, or it might turn out that the work belongs in an existing working group like either web transport or HTTP. So if you ask, does anybody feel like this work should not be done, I would keep silent, but that a working group should be formed, I'm much less sure. So I would currently say no to that until we get one answered.
Fair enough.
Krishnan, just like cutting in, Ted. So is your concern about the actual mechanics of doing this? Like, so you're okay with like some kind of work in this space, but you don't want to presuppose it's going to be a new working group that does it. Would that be a fair summary of what you wanted to say?
Ted Hardy speaking. Yes, Suresh, that's a fair summary. And I believe that there's enough work here that you might actually see some of the work go to one group and some of the work go into a new group or into a different group. It just kind of depends on how the scope gets pulled out. I just think the use cases may show us that the work belongs somewhere else. Some of the work, at least, may belong in something else other than our work.
Okay, thank you.
Spencer, you're next.
Thank you for queuing that up, Ted, because I think that some flavors of this work that different people have been talking about, I think should be done. I agree with Ted's comment about maybe not in a new working group, maybe not just in one working group. And God loves the quick working group, but it's not totally obvious to me that it even all belongs in one area, depending on what ends up being in scope. So I think that getting the charter nailed down really quickly is going to be really helpful towards getting this going.
Thank you, Spencer. Mark, 15 seconds.
Mark Nottingham. Yeah, +1 to what Ted said. I can't evaluate this charter in its current state. Should work be done here in this general area? Sure. I don't know that it requires a working group at this point. And I don't know that it requires a big effort. It could be just incremental components. So we need to figure the scope out.
Yeah, I think that's coming through loud and clear. And a part of it is just that, there's a good part of it that is figuring out how to be more specific and more precise and more tighter than the charter. And in doing that exercise, I think we might come out and find some things that we don't know yet, meaning that maybe it doesn't require a working group. But that's excellent feedback. And we are at time.
I think Martin was in the queue. I think he's DQ'd. Yeah.
Yeah, Martin DQ'd. And Martin queued up again. Martin, do you want to say something in 10 seconds?
apologizing for bouncing. I don't want us to meet again like this. I want us to work out the charter on the list. That's all.
Oh, absolutely. Yes.
Sounds good. Thanks, Martin.
Suresh, do you want to say something? Parting words?
Yeah. So I think, thank you very much for everybody for contributing. So there's like, at least in the charter, there's like a couple of issues that came up, and both of them important. I think one of them was like, it was kind of like underspecified a little bit. It was a little bit vague, like, what is the scope of the charter? The second thing is there are like too many specifics on how things are supposed to be done. I think like both of them need to be worked on before we go further. And I saw there's like a community of participants who are willing to do work on this, so that's a positive thing. But I really do think like we need to work a bit on the charter to scope it down a bit, specifically kind of like on the same lines that Cullen and Ecker pointed out a bit, and also kind of not presuppose the actual mechanism and see how things fall. So that's kind of falls back more to like, what Ted was saying, and I think like Mark was saying too. So I think that's kind of the directions like, we need to go, and let's do that on the mailing list. And personally, it's not clear like, where this would end up. Like I picked it up because it's like a tunneling thing in the area. So like we'll figure out like, where it needs to go. This work needs to go once we have a better understanding of what needs to get done. Thank you.
Excellent.
With
thank you,
that,
yeah, go for it.
Yeah, with that, thank you everyone for tuning in, entertaining us, and contributing. We will be in contact on the mailing list to flesh out this charter text and move forward. And I hope you enjoy the rest of your IETF week.
Thank you all.
I'll
all.
say one last giant thank you to the Secretariat for making this possible.
Yes.
Thank you.
Yeah.
Make your
Stay
choices.
safe, everyone.
Thank you.
Bye-bye.
Bye. Thanks, Jana and Chris. Great job. Thank you.
Yeah, thanks, cheers. And thanks, George.
Thank you, folks.
Bye.
Thanks. Nice. Yeah.